PixieNet is an implementation of an XNOR net for an iOS device. Here are examples of two frameworks that run CNNs on iOS in real time. On the left is TensorFlow that runs the Google Net model at 6.8 frames per second, and on right is AlexNet implemented in Metal at 6.13 frames per second. Existing convolutional neural network frameworks use double precision floating point values and therefore have a huge memory footprint. Here we present a comparison of trained model sizes of some common image classification networks. Currently, CNN frameworks optimize for speed on small CNN models. PixieNet is aimed at compressing existing trained models and running them quickly on an iOS device. XNOR nets present a mathematical approximation of floating point values using the sign function, which binarizes the values. A vector of real values W can therefore be approximated as the scalar factor alpha and the binary vector B. Here alpha is the average of the elements of W and B is a result of applying the sign function on W. Now we can represent a 64-bit double precision floating point value using only a single bit. Theoretically, this minimizes the size of the model by 64 times. Given this approximation, convolution of two matrices I and W can be approximated using the Hadamard product of their binary representations. For example, two real values can be binarized to +1 and -1, and this multiplication can be implemented as an XNOR operation where 0 represents -1. Experimentally, we observed that XNOR Hadamard product on two matrices of size 227 by 227 is approximately 68.95 times faster than matrix multiplication of double precision floating point matrices in Armadillo on an iPhone 6s. Now present some details of our implementation of PixieNet. We implemented a binary matrix class optimized for bit-level data storage and wrapped it in a binary layer class. A set of binary layers forms a 3D binary tensor, and a set of those in turn forms a 4D binary hypercube. A single binary convolution unit takes as input a 3D image and uses its 4D tensor of weights to perform normalization, binarization, convolution, and pooling if desired. The XNOR Network class enlists an instance of binary convolution for each layer of a CNN model. We first present our optimization process for convolution on a single AlexNet convolution layer. Our first implementation iterated through all channels for each filter of the weights sequentially. This is sped up by switching the iteration order as it minimizes the number of function calls to the IM2call function on the input. Since we store binary matrices as a linearized set of bytes, ensuring matrices have more columns and hence fewer bytes also boosts the performance. Finally, we can use the O3 flag for compiler optimizations to speed up the code. The runtime on a laptop CPU for the first AlexNet convolution layer is 3.1 seconds. At this point, bit-level binary network is slow on CPU.
That is illogical.
We also incorporated a floating point gem implementation considering binarizations in the network. Here we present the runtimes for each of the gem and binary matrix implementations for all 5 convolution layers of AlexNet on an iPhone 6s device. Gem runs through all layers in 3.7 seconds, and the binary matrix implementation runs through all layers in 188 seconds. Our current XNOR Gem implementation runs through a forward pass of the full AlexNet model in 5.5 seconds.
Seriously, floating point multiplications are faster than bit-level XNOR products?
Yes, Spock, this is why. Using 1 bit for every value implies that the system cache now contains more information in every cache 9-bit set. The runtime is slow because of the clock cycles spent in bit shifting operations when we store and access data at the bit level. Presently, the binary matrix PixieNet implementation only uses the C++ standard library. Further optimizations can be performed using SIMD and Neon intrinsics. Finally, optimizing for data storage at the bit level has trade-offs, as demonstrated in our project. In conclusion, binary values are small, binary XNOR is fast, and we are on the path to achieving a working online XNORNet implementation for iOS devices.
Fascinating. Live long and prosper.